I'm going to be your moderator for today's session, and our topic today, the overlooked hero, filtration's role in HVAC energy performance and capital efficiency, is going to allow us to explore how filtration and often overlooked operational variables are really playing a role in driving system performance and energy and efficiency overall. Also energy savings and compliance with today's evolving sustainability standards. So with us today, we have a really outstanding panel joining us. So first, we're going to hear from James from Blade Air, one of my colleagues. He works every day to driving next generation filtration design, and he's going to be breaking down how things like pressure drop and MERV ratings are really directly shaping HVAC energy loads, IAQ outcomes, more than people really think. And then next, we're going to hear from Robin from Sustainable Projects Group. He's a seasoned energy consultant who's helped hundreds of clients unlock millions in savings, and he's really going to zoom us out and show us where these overlooked operational variables fit into broader energy models and retrofit strategies. And he's also a proud member of AEE out in BC, AEE West, which is really great. And then lastly, we're going to have Harnoor come from Enerva Energy Solutions, and she's a leading voice in program design and implementation. She'll really be walking us through how to actually fund these upgrades that we're going to be discussing using real world incentives and ESG-aligned capital planning. And that's it. So James, I'm going to transition it over to you to get us started on your presentation.
Hi, everyone. I'm James. Thanks to Ava for the intro. As Ava mentioned, I'm one of the product designers at Blade Air. So a lot of what I work in is doing R&D, system design, that sort of thing. So it's all my bread and butter, and I'm gonna tell you all about it. I think 10 minutes is a bit of an aggressive agenda for 10 minutes. So I'm gonna stick away from maybe some of the more calculation and stick to more of a high level overview. So first we're gonna go over some filtration mechanisms and really how filtration works. And then I'm going to bring it back to what I mean when we say filtration is overlooked. And then we'll talk about ASHRAE 241, the new standard about air quality and infection control. Relate that back to the equivalent clean airflow, which is another new introduction from ASHRAE 241, and then wrap it up with some advantages of a new filtration technology. So these are a few different filtration mechanisms. These are really how your filter works. So you see there's inertial impaction, interception, diffusion, and then we'll talk about electrostatic filtration at the end. But really the thing to note here is that each particle, depending on its size, is going to be captured in a different way by your filter. So the largest particles will be captured by sieving. It's not on this chart, but it's really like a colander. If you ever, rinsed pasta after you cook it, right? The pasta is too big to fit through the strainer, so it doesn't is captured. Same thing with large particles in your filter. Moving down to the next size is inertial impaction. Basically, this happens when a filter particle or a dust particle, is too large to follow the air path. So obviously within a filter pad or air filtration media, you have many small air paths winding through all of the media. Larger particles have too much inertia and they can't follow that path. So they just smack into a filter fiber, lose their momentum, and they're trapped either by gravity or just get stuck in the filter. Moving down to around 0.1 to 1 microns, you have interception. So it's very similar, but this is when the particle is small enough to follow the airstream, but it still has some inertia, so it actually physically touches one of the filter fibers and then is trapped just by contact. The smallest one is diffusion, so that's less than 1 micron. And this is actually Brownian motion. So if you ever looked at something under a microscope and you see everything jiggling around, that motion is actually caused by the dust particle interacting with air particles. So the individual air molecules are hitting that dust particle and making it move because it's so small, it's able to be affected by just those tiny particles. So these tiny particles will exhibit a sort of random motion, and it's very likely that through their path through the media, one of those random motions will cause it to bump into a filter fiber and become caught. So when you're looking at air filtration effectiveness, if you're looking at the EU ISO ratings or the American MERV system, really what you're going to see is the percent chance that one of the dust particles moving through the filter is going to interact with a filter fiber in this sort of way. So you think, if I need better filtration, I just have to increase the probability that one of these particles is trapped in one of these ways. And if you see all of these all of these different methods of capture really rely on the dust particle coming into close contact with the filter fiber. So that really just means that if you're trying to achieve better filtration, you have to pack those fibers closer together. Now, what that also means is that your air paths are smaller, right? You have a denser media, so you're going to get more and more air pressure drop across the filter as you pack those filter fibers closer together. And that's a problem, right? Because then it means they're related. If you want more air filtration, you have to have necessarily worse air performance or worse energy performance. And that really creates an optimization problem for a lot of people in their air handling systems. Now, electrostatic filtration is a bit different. This actually creates a force that's going to attract dust to the fiber. So in this way, you actually don't have to have your fibers packed as close together because the radius around the fiber in which dust will be captured is larger, right? You're actually creating a force that's going to pull dust into your fibers. So there's a few different kinds of electrostatic filtration. Some of them called precipitators are used more for process air. So they actually have a grill on the inlet side that's going to charge the air and the particles, and then a negatively charged plate on the outlet, or I should say a positively charged plate on the outlet that will trap those charged particles. Now, the problem with this is because you are transferring charge to the air, you're going to produce ozone. And ozone is a byproduct of electrolysis in air. So if you ever smelled that ozone smell after a lightning storm, that's exactly what's happening. Because electricity is transferring to the air, you're actually going to break some of those chemical bonds of the air particles themselves and produce ozone. So that's a problem. It's great for process air that's not delivered to a space where people are, but we can't have it in a building. And then there's another filter called ASHRAE, which is sort of a passive static filtration. So it actually has a charge already applied to it when it leaves the factory. But then as it traps dust, that charge is absorbed by the dust that's being collected. So it loses effectiveness as it loads with dust. So there are some advantages. I'll talk more about our Pro filter later and how it tackles those problems. But electrostatic filtration, the main thing to note is that it's really seeking to decouple that relationship between the filtration effectiveness and pressure drop, because that's, I think, a huge problem to solve as energy engineers. So now I want to talk about what I mean when I say filters are overlooked. Now, I'm not sure how many of you come from a background of specifying air handling equipment, but an air handling equipment is a precision engineered system, right? You have oftentimes these things are in the tens of thousands, if not hundreds of $1,000s of equipment cost. And then you throw in this $5 filter and basically completely change the performance of the entire thing. So it's a bit crazy to think about, right? The fan, you have different blower types, motor types, if you want synchronous, VFD, if you want an ECM, brushless, whatever. There's many different kinds, and they're all different and have their intricacies to them. The control scheme, operating set points, they'll all change the performance of your air handling unit. The ductwork has to be precision sized, even simulated in complex scenarios to make sure that it actually works as designed. Your coils, you have to change pretty much everything about them, the piping diameter, the fins, the fin type, spacing, the number of rows, even the piping layout through the coil to get best performance. And then if you've seen an energy recovery core, basically to recover some of the air from your exhausted airstream, there's many different factors there as well. Your system type, core material, bypass. I won't get into them all, but very complicated. But then filters, often it's just, what MERV do you want? How big is it? Right? This is another component of your air handling system, I think, that needs really some careful thought, but often doesn't get it. I think a lot of people wouldn't even know what kind of filters they use, if they're, a fiberglass pad or a pleated media, or if the pleated is it paper, is it polyester? A lot of people don't really know, right? A filter is a filter. We also don't monitor them as much as other systems, right? So your fans, your coil, all have many data points that are tracked by a building automation system to make sure that your air handling system is working as it's designed to. Now, filters don't have that. Usually there's just one, maybe, just a pressure drop, a simple, basically calculation or comparison of the upstream static pressure and the downstream static pressure. And we use that to check, is the filter too loaded? Am I overloading the fans? But it doesn't actually show your performance. It doesn't actually tell you if you're filtering air. So what can happen let's say you have a filter alarm set that it will trigger an alarm in your system to tell you your filters are dirty if they pass 1 inch of static pressure loss. But if you actually see this picture here, this is a filter that has completely failed. It's broken because the pressure drop got so high and maybe it got moist, but the cardboard has folded and now air is going right through your filter. And now you have no pressure drop. But your system won't tell you that because you're not measuring really your filtration performance, right? You have no filtration in that system. Air is going right through your filter. All that dust is getting into your coils, your fans, your dampers, but you're not going to see that because you haven't, there's no capture of that information. And this is a huge problem, especially for coils, right? The coils will foul. Basically, you'll have dust or biofilm accumulating on those energy transfer coils, and you'll get worse performance. So cooling is most heavily affected because it's a moist and damp environment. Heating, less so because the hot coils will self-disinfect a little bit. But it really shows that the industry, I think, for a long time, filtration was a checkbox, right? You had MERV 8, you have a filter, great, you're good to go. But I think recently, especially after the COVID-19 pandemic, we've seen a huge change towards more strenuous filtration. And a lot of that actually comes from the ASHRAE standard 241. So it was released in 2023 after the COVID-19 pandemic. ASHRAE had been releasing some documents with best practices and recommendations throughout the pandemic, but it wasn't codified and really fully released until 2023 because it obviously requires a lot of testing, modeling, that sort of thing. And really what it is a standardized modeling system of infection risk in buildings. It uses the Wells-Riley model to measure risk, but basically it's a CFD simulation to say if there's one person coughing in room A, is it going to make everyone sick in room A or maybe room B, the entire building? What happens? It also defines a new operating mode called infection risk management mode. So if we were to have a new pandemic, and let's hope we don't, there's a new operating system, a new operating mode in your air handling system to account for that. So if you need to have people indoors, but there's an ongoing risk, you can increase ventilation rates, increase air cleaning and filtration to really keep everyone and all your building occupants safe. It also officially recommends MERV 13 for commercial air systems. So a lot of people have been changing to MERV 13 and finding that now all of a sudden their system doesn't work because you have this really high efficiency filter, but it's also blocking a lot of air. We actually did a pilot project in the distillery district where one of their fans had actually completely burnt out because there was so much stress on the system from that new filter that they needed a new solution. One of those things in that infection risk management mode is increasing your ventilation. Now, that's great. We have more fresh air coming into your building, keeps everyone comfortable, but it's not always really economically viable, right? Let's say you're in Toronto, it's in the winter. It's a lot of energy to just dump and let's say double your filtration or your ventilation rate, I should say, because you have to heat, humidify, right? It's a lot of energy to get that fresh air. So what ASHRAE did is they made this equivalent clean airflow standard. And it might be a little confusing from this chart, and I'm also going quite quickly, granted. But you can replace a portion of that ventilation air that you need with cleaned and recirculated air. So if you have some sort of air filtration system or air cleaning system, a portion of that fresh air needed to keep people safe can be replaced with just recirculated cleaned air. And that's really where we come in with the Pro Filter. Really, it's just to allow more variability for operators to meet these requirements because the requirements for ventilation are extremely high under ASHRAE standard 241. And that's because it's obviously there's a huge risk, right? Bioaerosols, COVID-19, God forbid, some other new pandemic. There's a genuine risk to human health. So these standards are, very, very stringent, which means they had to allow some wiggle room for people to meet it in other ways because a lot of systems just frankly could not meet this amount of ventilation at all, even if they took the filters out and just dumped fresh air in. And then one more problem is it also supposes that the outdoor air is clean, right? While it might be so in a sort of bioaerosol sense, there's no infectious particles just floating through the air outdoors, it doesn't mean it's clean. If you're, say, downtown, it's a smoggy day or there's a wildfire, you're actually making your indoor air quality worse because of that ventilation, because you're bringing in those pollutants if you don't properly account for them. So this is our solution. This is the Pro Filter. It is an active field polarized filter, which means we actually pass a charge over it. The unit is constantly charged by 24 volts AC, and it actually steps that up to over 8 kilovolts at the media. And what this does is it basically creates an electric field inside that metal box you see there that's going to pull dust particles inside. Now, because it's electrostatic, but there's no charge being delivered to the air, we're just polarizing molecules, not ionizing them. We don't produce any ozone. So we're one of the only ones that are no ozone certified, works with well, as well as UL 2998 tested to produce zero ozone. And if you remember way back 10 minutes ago talking about electrets, we don't have any loss of charge because there's that constant refreshing of power into the unit. So we maintain filtration performance even as that dust pad or that pad loads with dust. We also do what's called depth loading instead of face loading. So in my example of the sieve, I think maybe a coffee filter would have been more apt given our topic of conversation. If you ever use a paper coffee filter, you'll see it flows really quickly at first and then slows down until that last little bit of coffee is just barely dripping out. And that's because the filter has front loaded, right? Those smaller particles get stuck in the front and then block some of the air paths or coffee paths. And as you filter more and more, you have fewer and fewer paths for that to go through. So you more pressure drop, less flow. We don't do that because we're charging the entire pad. Every single filter fiber has surface area that can trap dust. So you have much more room to trap dust without getting that associated pressure rise. So it really solves that problem, right? We've now decoupled the filtration performance from the pressure drop. We have a MERV 13 performance at a pressure drop close to a MERV 8. Now, I think something to note is that also there's a sort of myriad of other benefits associated with electric charge. So firstly, we actually have VOC reduction. I think it was over 40% reduction in VOCs over a 48-hour period we tested, again, in the distillery district. And that's because a lot of these VOCs are polar molecules. So if you've ever done that science experiment where you rub a glass rod, you hold it up to water stream, and that water stream bends, very similar concept to VOCs in our filters, right? They will be attracted by that electrostatic charge on the filter. They'll be trapped and eventually captured by the filter and even by some of the dust that's already loaded on the filter, basically becomes impregnated with these VOCs. Now, also there's some studies showing viral inactivation due to the electrostatic field. It's a bit harder to quantify because you have to look at dwell rates and the airspeed, but essentially, if you have a strong enough electrostatic field, you're basically shredding viral particles at a microscopic level, right? There's so much force from that electrostatic field that it's destroying virus particles. And in the same way, we also have mold spore deactivation and reduction. So there was a mold spore Petri dish spot test done upstream and downstream of our filters, as well as upstream and downstream of a typical MERV 13 pleated filter. And we had a much higher mold spore reduction from our electrostatic filter. Again, both because we're trapping more particles because of electrostatic force, but then also because we have that viral deactivation from the electrostatic field. In summary, I think I really want to mention that increasing ventilation, while it is the gold standard of indoor air quality because you're bringing in fresh, sort of fresh air, it's also very expensive and not always feasible, right? You can't just double your air filtration or your airflow rate. If you're in the middle of summer, you have to dehumidify and cool, or in the middle of winter, you have to heat. That's not always something you can do. You're also it's tied to the air quality outdoors. If you have a bad air day, there's nothing you can do by opening a window, right? So filtration, it might often be overlooked in an HVAC system. I think sometimes it's just a drop-down list of what filters do you want? MERV 8, MERV 13, who cares? Doesn't matter. It's really another component that should be precision designed just like the rest of the HVAC system is connected to. I mean, you see these $100,000 setups being completely bottlenecked by a $5 paper filter. It boggles the mind. So I think there's been a bit of a change in the industry. And I know the HVAC and building industry is slow to change, but it's something that even over my few years in the industry, I've noticed a distinct market difference in the filtration that people need. And then air cleaning systems like our Pro Filter can help you meet these ECA targets for infection control strategies while saving some energy versus outdoor air ventilation. And then it's also important to really look at a system in a holistic level and really audit your system to find out where there's potential synergies, right? How can these technologies work together to really deliver better results?
Thank you so much, James. Really appreciate that. Definitely a great technical breakdown. And now we're going to be shifting over to Robin, who's really going to take us on a little bit of a systems level lens and share how these underrepresented variables play a role in energy planning and modeling. So with that, Robin, it's all you.
Good morning, everyone. So the overlooked hero, filtration's role in HVAC, energy performance, and capital efficiency. I will look at this from an energy auditing perspective, but I wanted, from an energy point of view, I'm talking to property managers, municipalities, people who have lots of buildings, and they have two types of buildings. They have their existing buildings or older buildings, and they have newer buildings. These two type of buildings are there because it's their responsibility to have a healthy portfolio, because they are investing, they're investors, or they have, the building has an operational value. But what have these two buildings in common? They all use energy, and because they use energy, they cost something. And the additional problem here, they have GHG emissions. So this is real-time energy audit data. But to highlight what James already said, there's a huge diversity of energy. But look here, ventilation takes already in this building 12%. Then we have also heating and cooling that also may be impacted. And our goal, if we want to look from a sustainability point of view, is we want to reduce our CO2 emissions or our GHG emissions. So this is the gas part, and then we will electrify more. But we also know that certain grids are not as clean, so this can also contribute to emissions. So the final goal is to reduce this one as much as possible and also replace equipment that is more energy efficient. But other challenge we have now is we signed the Paris Agreement, and we want to also become more sustainable. And the goals we need to achieve now are maybe 20%, 30%, 50%, or even net zero. And if we talk about these larger projects, well, these projects cost a lot more money. And to achieve these savings, we cannot just do a lighting upgrade. No, we need to look at the holistic point of view, and we need to look at better building envelope, better HVAC systems, better automation. Because if you look at them from a holistic point of view, you will have better performance. You may be under or over engineered equipment. So that's how you achieve these goals. But yeah, that is a problem in our industry. So what is our current situation if you have a portfolio of buildings that you might have already older buildings that are not that energy efficient, and you can see they use a lot more operational carbon and a lot less embodied carbon. And to make your portfolio more efficient, you will or tear your building down and put a new one there, have a higher embodied carbon and a lower operational carbon, or you will do deep energy retrofits and try to achieve the same. What are the driving factors of that? Because trust me, in the audience, we're probably very sustainability minded, but the industry is not waiting on all these cool sustainability projects. This is done by regulations. So I'm based in the city of Vancouver, and so how does that work? Buildings larger than a certain amount of square footage need to start reporting their emissions. Same one is, for example, in New York, the local law 97, where again certain type of buildings need to report their energy emissions. And then for you guys locally, Toronto or Ontario, you can see here buildings larger than a certain amount of square footage also need to do mandatory reporting. And what's the impact here? People don't like it because it is suddenly properties rate a different property value. So if you have a residential building or a certain property that is maybe $100 million and another one is $100 million, Well, the other one, this one is very efficient, and the other one is less efficient. So the one that is less efficient will cost a lot more money to do deep energy retrofits or replace it. Also, sustainability is a cost center. Like if you think about it, 20 years ago, 30 years ago, where nobody was talking about sustainability, you had buildings with large inefficiencies or holes in it. And if you need to make these buildings better, you need to upgrade your equipment, and that costs a lot of money. And then there's also lots of extra work, ESG reporting, and so on. So it's not something that people really like. So what can we do? Yeah, sustainability is a cost center, but let's try to make from this challenge an opportunity. If we do it properly, so if we have a building that is performing better, it will increase the property value. It will improve the quality of the building because, like James also said, people might forget that we had COVID, for example, but the cities or buildings have changed a lot. And so if you have buildings that are more sustainable, performing better, you can see that people also are willing to go more to these buildings. Then there are energy savings. So you will save money on the energy savings, and you will also reduce your carbon footprint. The question now is, how do we get these things done? Because these capital projects cost a lot of money. And so our next speaker will go even deeper in this, but we see that if you start embracing different financing models, that it's easier to do these larger capital projects, especially when you go into 20, 30, 40 or net zero projects. I don't want to go too deep in there, but so you, for example, you have on-bill financing where BC Hydro, Fortis BC, Sask Power, every utility provider has certain models available. So upfront cost is low, risk to owner low, and it's for small to medium retrofits. Typically, you get a rebate for a light bulb, for example. Another one you can use is energy as a service. So for example, if you start generating your own electricity with solar, or you have district energy where you can start selling energy, then you have the property assessed clean energy where you have tax benefits when you upgrade your buildings. Then the typical utilities and incentives, ESCO models, that where you create, especially from larger projects, your capex becomes an opex. Performance-based contracts that are really closely tied to ESCO models, where you use measurement and verification, or even carbon credits. You create your own carbon credits that you trade. But for what we find in the industry is talk to people like Blair there, talk to people like Enerva, and check how you can combine all these projects together, because it is something that is happening. We need to make our buildings more sustainable. It's complicated, but if you use it properly, there are even ways to fund the project for 80%, 100%. I've even done projects where the customer made money on improving the buildings. Then I want to conclude with this: target, time, and investment. So if you have a target, let's say you need to meet your 50% here. If you want to do that, also think about time. So you have the sales cycle that needs to be done, the implementation that needs to be done, and it all takes some time. Even projects we want to start maybe today and only get implemented next year, you can see if you want to meet your goals as somebody who manages multiple buildings, it can be complicated. So I'm going here just a little bit in detail. This person want to achieve 50% of GSG savings. Well, if we invest a small $200,000, you will only achieve maybe 10%, and the accumulative savings here collected over 12 years will only have a payback. So you need to consider the financing models, timing, and investments all together.
Thank you very much, Robin. Really appreciate that. We will now be transitioning to our third and final presentation now. So we're going to be moving to Harnoor, who's going to be diving into the practical side of really implementing these types of upgrades and discussing how they're being funded through incentives, capital planning, ESG frameworks, all of that great stuff. So take us away.
Good morning, everyone. So my name's Harnoor, and just for background, Enerva is contracted by the ISO as their third-party partner, and we cover retrofit and energy performance program under the Save on Energy umbrella, as some of you are familiar. So in this presentation, I'll be covering the incentives that are available for indoor air quality improvement retrofits and how you can take advantage of them, along with all the other benefits that were mentioned by the previous panelists. So there are some of the benefits that go hand in hand with improving indoor air quality and filtration retrofits. Filtration upgrades should be incorporated into long-term asset management and capital planning. This does prevent any occupancy discomfort that is caused by emergency repairs, and it gives enough time to enroll in incentive programs, because a lot of the programs require you to enroll at the planning stage and before a quotation is issued. And in addition, they do extend the equipment life, reduce maintenance costs, and they lower the overall operating expenses of the facility. If we talk about from an ESG perspective, filtration does contribute to Scope 1 reductions via HVAC efficiency, Scope 2 via reduced electricity, and Scope 3 by improving air quality and health outcomes for tenants and employees. Now, this positions the indoor air quality investments in not just operational improvements, but also a part of your broader ESG narrative. And it becomes easier for you to project this to your client or to other members of the team when you incorporate it into your ESG narrative. Yeah, so better filtration, also when it is coupled with smarter ventilation, it reduces the workload on HVAC systems. And this means that you have lower fan energy usage due to reduced resistance with efficient filters, less heating cooling demand, which results in better airflow control and thermal balance, and which also results in smaller carbon footprint from your buildings. And lastly, COVID has also taught us that how important indoor quality is for occupants and how it directly ties in with their health and productivity. Now I'll go over some of the several financial incentives available across Ontario that support HVAC, indoor air quality, and energy efficiency upgrades, including the filtration retrofits. Now, these rebates help offset upfront costs while aligning projects with both environmental goals and capital planning. In Ontario, the Save on Energy, which is run by the Independent Electricity System Operator, ISO, offers 3 key programs, which are the Retrofit, Energy Performance Program, EBCX. Just a few details about Retrofit program. It offers incentives for high efficiency HVAC equipment, controls, filtration systems, and you can also bundle the filtration with other measures like smart controls, demand ventilation to increase the ROI and qualify for multi-measure incentive programs. It is ideal for upgrading older equipment with more energy efficient alternatives. The Energy Performance Program, it rewards the buildings for measured energy savings over time. So it's not just equipment upgrades, but the filtration projects that are paired with energy savings can perform well under this program. And the EBCX offers financial incentives to commercial building owners to hire qualified commissioning providers to undertake building recommissioning at their facilities, helping them realize energy savings for improved facility operations and maintenance and business practices. So these are the different, like the 3 programs for the ISO. And then on top of that, Enbridge Gas also offers incentives for ventilation upgrades that improve the energy performance, including demand control ventilation. You can definitely work with your energy advisor and they can guide you through the process for the Enbridge incentives. These are especially valuable when bundled with heating system upgrades such as ERVs, HRVs. There's custom measures, there's prescriptive measures. So whatever is best suitable for your business, the advisor can help you walk through that. Then the NRCan does provide some federal incentives and grants as well for commercial and institutional buildings. that demonstrate GHG reductions on energy performance improvements, such as the Green Municipal Fund. And then there are other programs as well that they can be found on their site. There's always new ones coming up and the older ones closing. So they're really, moving with the market, what the requirement is. So just to cover retrofit program a little bit in detail, there is a custom track that is designed for the retrofit measures that don't fall under the standard prescriptive track. The prescriptive track has a set level of incentive for each measure, but because we're talking about a technology that does not fall into this prescriptive track, so I thought it'll be useful to dive a little deeper in the custom track. And this is especially useful for innovative or complex projects like advanced filtration systems or integrated IAQ solutions. To qualify, it does require a little bit of detailed documentation, which includes the energy savings calculations, and that can definitely be, if you're have a contractor that you're working with, they can definitely help you with the calculations. The project quotations, the invoices or cost estimates, and then these help the participant assess the project's return on investment in terms of energy and emission savings. It does get paid out after the project is completed. So once all the documentation is submitted, the application gets processed and the check is issued. Now, the key advantage of the custom track, custom project can be bundled with other upgrades to increase overall impact and funding potential. Some of the examples, network lighting controls for occupancy-based energy use, HVAC redesigns, chiller replacements, variable speed drives. So there's a number of options that you can choose from if you want to bundle the measures and apply for them together. And it does help create you a compelling business case as well and improve your project's ROI and eligibility. Next, we will go over the EPP, Energy Performance Program. So when you're considering IAQ and filtration upgrades, it is critical to take a holistic view of energy performance because usually savings don't just come from an equipment upgrade. It also comes from the interaction between the operations, occupant behavior, and the capital investment. And that is exactly what this program is geared towards. This does mean integrating the operational improvements like ventilation scheduling, behavioral changes such as managing occupancy and air usage, and capital upgrades, including high efficiency filters, VFDs, or sensor-driven demand ventilation. Energy savings and hence the incentives are determined by comparing your annual metered energy use to a baseline energy model. This approach ensures that actual performance is incented and not just the theoretical savings, and which I think drives higher reward. Now, to ensure fairness and accuracy, data is normalized for weather, occupancy, and other variables like production schedules, which is mostly valid for industrial facilities, or COVID-19 impacts, which can be a big factor for the offices since the occupancy rates are not back to normal. This does allow filtration and IAQ-related savings to be accurately captured, even when buildings operate differently year over year. Because we all know that if it was operating 2018 in some other way and 2021, there's definitely going to be a difference. So the baseline is adjusted accordingly. And there is a tiered incentive structure, which makes the case even stronger, meaning 15 cents per kilowatt hour during the on-peak hours, which are the summer hours. That's when the load on the grid is the strongest. The 4 cents per kilowatt hour when it's off-peak hours. So whenever you see the savings, the incentive is automatically tweaked whenever your maximum savings are. And this does encourage strategies like demand control ventilation, smart filtration scheduling during peak times, where the energy benefits are, again, the highest. Then an additional advantage is the availability of, upfront incentive payments, which does help cover the capital cost and the ease of budgeting. That's available as 4% of your baseline consumption. And you can definitely talk to the advisor and, if you're going to be eligible for that or not. Some of the requirements for EPP are it's 3-year program, incentives paid out annually. There's no penalty for dropping out or not meeting the 3-year mark. The 5% savings criteria is in place by the ISO in order to encourage participation to undergo retrofits and upgrades. However, again, no penalty. Incentive does get paid out annually for whatever the percentage savings are. Even if it's 2% or 1%, it's paid out according to that. And of course, facility should be located in Ontario with a general service account of 50 kilowatts, which is mostly for commercial and institutional buildings and obviously for industrial ones. Then there should be a 12 months of hourly meter data for each facility. That is available through your local utility, the LDC, and it can be obtained via Green Button. We've helped a number of facilities get connected with their Green Button availability and their to their utility, and that just gives you like the data set for the year. Now, certain upgrades might require a baseline adjustment or might be ineligible altogether, such as on-site energy generation, solar panels. These are typically excluded because it displaces the grid electricity rather than reducing the building site demand. And if you've already received funding from an ISO initiative, such as the retrofit program that I covered before, there's a clause on not double dipping. So if you claimed, for example, a retrofit incentive in January, you'll have to wait for a year for January 2026 to enroll this program in EPP, which I think is a good follow-up because you've got the incentive for the capital replacement, and then whatever the residual savings are, this captures that. And just a bit more about how the EPP portal works is an online portal that's used to manage the entire application and reporting process, makes it simpler and more accessible, even for the companies that don't have any in-house energy modeling expertise. The portal has automated tools that handle the baseline energy modeling, performance tracking, annual energy savings calculation, and you get access to benchmark featuring as well. There's built-in data analytics that are going to support progress monitoring and help identify further opportunities for indoor air quality or energy improvements. So even if you want to check your building's performance in, let's say, 4 months, you can definitely upload the data and see how does it perform to the previous 4 months. Now, it encourages the participants to make data-driven retrofit decisions while streamlining compliance and maximizing the incentive potential. And you can upload more than one facility at a time, multiple facilities. These are just some of the tool screenshots of the tool that I thought might be useful that are available on the portal. As you see, there's a baseline tracker. So once it's been accepted, then it'll move to the next step. If there are further variables at play, such as occupancy mostly, then the technical reviewer will reach out to you with questions, and we might need a bit of more data, such as the BMS log or operating schedule in industrial facilities. And then there is a time series display of energy consumption. So I've included some of the key contacts for retrofit EPP and my email as well, and for the Enbridge, the link for contacting the Energy Solutions advisor. So once you send them an email, they'll connect you to the one that's the best suited for your respective industry.
Amazing. Thank you so much, Harnoor, and to all of our panelists now for such valuable insights. I am going to be calling forward the rest of our panelists to just come, and we are going to enter into our Q&A portion where we will be able to just answer some of those questions that I did see roll through throughout our presentation. Just to read it out loud, there was a question, traditional filters are mostly either washable or replaceable. What category does the Pro filter fall under, and what lifespan before it needs to be replaced?
I can take this one.
Yeah,
live.
yeah. James, do it. Go ahead.
So the Pro filter has a frame that is standard. You keep the frame, but then the media is replaceable. So the media will come rolled up in basically a vacuum sealed pack. You open it up and you just replace the media. So much less waste compared to a traditional pleated filter because you're only replacing the media, not the entire frame itself. but it is not washable because obviously you'd have a lot of dust captured there. It just wouldn't be very effective. The lifespan, we usually double whatever you're getting from a standard pleated filter. So if you get, say, 6 months from a typical filter, we go up to a year. We try not to go above a year and a half, 2 years, because at that point, the meat is old, it needs replacement. But yeah, it's at least doubled. And then hop over to the Q&A or the chat section. Said asked a question about the no ozone testing. So for UL 29998, the threshold is 5 parts per billion, which is a minuscule amount. It's actually barely above the average atmospheric concentration, and we're below that. I think Aidan has correctly identified around 2 parts per billion. So it's a essentially unmeasurable change, which means we're not producing any ozone.
Thank you, James. Appreciate it. So yeah, those 2 questions were answered. And now we did have one roll in also in the chat from Lucas. What measures can be implemented to safeguard HVAC ductwork on rooftops from overheating during the high temperatures of summer? Additionally, have there been any discussions regarding the effectiveness of high solar reflectance insulation? I guess, James, I could give this back to you, considering you are more of the technical expert on our panel here.
Sure. Yeah, it is actually a huge consideration, especially if you're cooling, because that you're going to lose effectiveness if you don't insulate your ducts. So I think usually it's I could be totally misquoting here, but I think it's an R value of 10, I want to say. This is recommended for ducts so that you're not losing that effectiveness due to the overheating of ducts, as you mentioned. A lot of time they're painted white, or they will have a cover on top. So on top of the actual equipment, you'd have a separate cover piece that shields it from weather. So having that shield system be painted with say a white color. I think, Lucas, you mentioned we were discussing earlier titanium dioxide. So with some high reflectance to reduce that urban heat island effect, and then that ladders into several other energy standards. Even LEED, I think, has credits for high emissivity or emittivity coatings to reduce thermal absorption from sunlight.
That was quite insightful. I guess when people are thinking of the questions, some of my key takeaways were like to look at a system at a holistic level, right? So James, you mentioned that and how it ties into the health and productivity and also like reducing the maintenance cost. Robin, you mentioned how, sustainability, although it's a cost center, but we can always look into these financial models, right? Harnoor, you took us right into, how the utilities, the ISO, and how, these incentives are available to take advantage of. So thank you for bringing our attention into these and also like enrolling early on in the process, right? So the faster, the earlier we know, the earlier we can take advantage of these. And on a subtle note, I was also reminded how energy engineers like us love our acronyms, and we take, pride in using them. And it's, so that was pretty cool. On that note, just want to do a quick plug here for, our membership. So yeah, if you're a member, we thank you very much. But if you're not, we would really encourage you to, take advantage of this. So if you are an energy consultant, if you're a government rep or sustainability professional like myself, it's just $60 on an annual basis. And if you're on LinkedIn, we would love for you to join our growing community. We are nearly 1,700 professionals, such as yourself, and so you can stay up to date with our events here. And yeah, again, our heartfelt thank you to our presenting team, Ava, James, Robin, Harnoor, I think, and also our participants for taking the time of their busy schedule to join today's presentation. And we hope you found it insightful as much as I did. And if you have any questions, we would love to hear from you. That's our email, info@aeegta.org. And we hope to see you in our next in-person or virtual event. So on that note, thank you once again, and hope you have a great day.
Thank you, everyone.
Thanks, everyone, for joining.